All right, ladies and gentlemen, so we are going to take some notes to review the methods of adding integers that we have been practicing this week. So you're going to start by getting out your notebooks. Here's my notebook. And the first thing you're going to do is flip to your first page of table of contents, and you're going to go to number 7, and you're going to write the title, Adding Integers. So we're putting adding integers on page 7. So after we write the title, we're going to turn to page 7. Now, as you're taking these notes, feel free to pause at any point if you need to rewind and redo any of them, or if you missed something or you want to review, you can do that as many times as necessary as we work throughout these notes. So our title for this page is going to be Adding Integers. Remember, an integer is a whole number, but could be positive or negative. A whole number, but could be positive or negative. All right, so we talked about 3 different methods. Method 1 that we used was the 2-color counters. Okay, for each of these methods, what we're going to do is we're going to write some very simple steps to review the steps of the process, and then we're going to do some examples. So what I want you to do right now is take your page 7, and I want you to fold it in half, just like that, and then open it back up. Okay, then we're gonna draw a line down the center. So on the left, we're gonna write our simple steps, and then on the right, we're going to show a few examples. So when we were using the 2-color counters, the very first thing we would do is represent the problem. Okay, so if our problem was, let's use the example, -7 plus 5 equals. So if our problem was -7 plus 5, we would lay down 7 negative, 2, 3, 4, 5, 6, 7. And remember, we could use red for negative and yellow for positive. That's what we used when we had the actual counters. Or we can put negative signs and positive signs down. Does not matter. So we have 7 negative and 5 positive. 1, 2, 3, 4, 5. Okay? So our first step is always to represent the problem. Our step 2 is to cancel pairs of opposites. Okay? So we find opposites and we cancel them out. Here's 1 pair, 2 pair, 3 pair, 4 pair, 5 pair. Step 3, our solution equals what is left over. Okay, so we can see here we have 2 reds left over, so our solution to -7 plus 5 is -2. Let's show one more example. Let's say we have 8 plus negative 3. So again, I said we could do the circles. Those look a little bit more like the counters we were using, or we could do positives and negatives. So this time let's show that. So we have 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. And 3 negatives. 1, 2, 3. So that was step 1. Represent the problem. 8 positives, 3 negatives. Step 2, cancel pairs of opposites. We can get rid of 3 pairs. And then our solution is what is left over, which is 5 positives. And remember, we do not have to show a sign if it's positive. All right, on to method 2, which was using a number line. Okay, so we practiced using number lines to add integers. When we were using a number line, our very first step was always to start at the first number in the problem. Okay, so we're starting at the first number in the problem. So let's do an example of negative 4 plus 8. And we're just going to draw a very quick, simple number line. It doesn't have to be anything crazy. We know we need at least to go to negative 4, so let's just start negative 5. Negative 4, 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. And we can always expand this if we get through the problem and realize we need more. Okay, so our first step is to start at the first number in the problem. So the first number we see when we see the problem is negative 4. So we're going to put a point at negative 4. Step 2, we're going to move left or right, depending on what the second number is. And we're going to move this many spaces. So we're going to move left if we are adding a negative. But we're going to move right if adding a positive number. Okay? And it's according to the number. So this is a positive number, and it's 8, so we're going to move to the right because we're adding a positive 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. So the ending point is our solution. Okay, so we started at the first number, which was negative 4. We're adding a positive 8, so we're going to move to the right 8 spaces. Wherever we end up is our answer. So negative 4 plus 8 is positive 4. Let's do one more example using a number line. This time, let's start with positive 3 plus negative 6. Let's just go ahead and keep our number line at negative 5 to 5. So So -5, 4, -3, -2, -1. And you don't have to label all of them in between as long as you can go back later and be able to find the correct number. Okay, so we're gonna start at the very first number, which is +3. I'm adding a negative, so that tells me I'm gonna move to the left. And I'm moving to the left 6 places because it's a -6. 1, 2, 3, 4, 5, 6. So my solution to 3 plus -6 is -3. All right. So after we practiced with both the 2 color counters and the number lines, then we finally discovered that there are some rules that we can follow every time. So our method 3 using the rules. Okay, now it's great that we have a set of rules we can follow. It especially helps with problems that have greater numbers, right? Because we don't want to have to draw a number line that has 36 and 75. And we don't want to have to lay down that many counters or draw a picture like this either. So it's nice to know the rules, but when you're really thinking about the problem, you want to use these ideas to kind of help make sure you have the correct answer or reasonable answer. Okay, so we have 2 sets of rules depending on what our problem looks like. Okay, so if the signs are the same, our first rule. Okay, so if we have a problem with 2 signs that are the same. Now, when I say signs, I mean the sign that goes with the number, not the operation sign, but the sign that goes with the number. So 2 positives or 2 negatives. If the signs are the same, we add and keep the sign the same. Okay, so let's give 2 examples of that. We've been doing this since probably 1st or 2nd grade. If we have 4 plus 7, we keep the sign the same, or we add 4 plus 7 is 11, and 4 and 7 are both positive, so we keep it positive. The same goes for 2 negatives. So if I have -11 plus -20, again, I don't want to have to sit here and draw a number line, but I know that if I'm at -11 and I have to go 20 more spots to the left, then I know I'm going to add these 2 numbers because I'm getting further to the left of the number line, left of 0 on the number line. So I add 20 plus 11, which is 31, and I keep the sign the same. So if the signs are the same, so 2 positives or 2 negatives, I add and keep the sign. Okay? So that means if the signs are different. So I'm adding a negative and a positive, or a positive and negative. If they don't match, if the signs are different, we're going to subtract. So imagine crossing out pairs of opposites. We're subtracting, we're crossing out pairs of opposites, and keep the sign. Of the number with the greater absolute value, so of the greater number, right? Because the positive number is always going to technically be greater, but we're keeping the sign of the number that would be greater if we were finding the absolute value.